Section 1.2 of CCNP routes expects you to know about different hazards that you can face during your life, your work life. When we are working with Cisco devices, we expect to see such hazards, and we are supposed to be, prepared to, you know, uh, uh, to face these hazards and, correct all of these. The first one talks about Unicast. What Unicast hazards can we have? Assuming that I have a switch here, and this is my switch. Let me move it a little bit down. And this switch has about, for example, 12 ports. This switch name is switch 1, and it has different ports. This is port 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can see that I can count, huh? So let me draw these devices. This is, for example, computer 1, this is computer 3, this is computer, for example, 10 or whatever. And just named it. This is C1, C1, what I am writing, C1. This is, for example, C3, and this is C4, 5, 6, 7, 8. Okay, now switch maintains a table in its memory, and its table is called CAM table. And of course, in any switch, you can call it MAC address table. The MAC address table has a mapping of ports and computers that it is connected to. You see that when a computer sends a message, when a computer sends a frame, it has its own MAC address and its, source MAC address field in the frame. For example, this is a frame, and the frame has a header. What kind of frame is this? Let me draw a better frame. Assuming that this is a frame and it has different parts. The first part is called header, and in header we can see a source MAC address, and then we can see a destination MAC address. Then we have a source IP address, and then we have a destination IP address. And then we can have different other items, such as types, such as the content type, and the rest of that is data. And finally, we have a trailer here. The trailer is just a CRC, cyclic redundancy check, or we can call it a checksum. So this data part is something that the application wants to send to other computer, also to other application. I do not care about this part. What I care about is this first part. This is called header, and we have source address and destination address. These are MAC addresses, and you know that when we send a frame of data, we have our MAC address on its source address field. Now, when a switch receives one of these frames, it easily finds out what is my MAC address. For example, computer 1's MAC address is ABCD. I'm not going to write all of them. For example, computer 1 has a MAC address of ABCD. So it writes ABCD, and then writes this as port 1. The port number is 1. Or for example, pass 00, pass 01, whatever. The port number is important for me. This is port number 1. Okay, I know that ABCD is connected to port number 1, and I know that ABDD is connected to port number 3, and I know that DABD is connected to port number 8, for example. Okay, now I check the destination of this packet, of this frame, and I see that the destination, it is right, it is, DABD. So I know that this should go to one of the devices connected to me because I have such thing here, DABD. And for this, I check the port number. I find out that this is number 8, and I know that it should go through port number 8. I am not forwarding that to any other port. I just forward it to port number 8. That is what I call it switching. And because This is kind of intelligent. It is called intelligent switching. We can have bridging, of course, and the bridging and switching in this context are the same. So when we talk about bridging table, actually we talk about switching table or CAM table or MAC address table. When we are talking bridging concepts, we are talking switching. And actually the process is this. We check the destination MAC address, and if we have an entry in our CAM table for that, we check that entry, find out the port that we need to forward this frame on that, and then put this frame on that interface's queue, and it is going to be forwarded to the destination. This is the normal behavior of the switching mechanism. So, so what is the problem with that? We know that not all of our packets have a destination IP address. Of course, they have destination IP address, but some of them do not have a specific destination IP address. I mean MAC address. I'm sorry about that. Some of my frames do not have, destination MAC address. Some of them may set it to all Fs. It is going to be F, 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 dot, F, 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 dot, another F, 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 F. This means that this is a broadcast frame. This is going to be a broadcast frame. And some these devices issue broadcast frame. For example, when they are trying to find the DHCP server, they send a message that is called DHCP discover, and DHCP discover has a destination of non-existent. Have a destination of I don't know what. I can call it this the I don't know what destination, or I don't know where destination. So the HTTP discover is sent to this, and all devices in my network should process this message, because this may, relate to them. For example, the HTTP server is listening to them, but other devices are listening to this kind of messages because they assume that there may be something in that for them. So this is going to be forwarded to every port except the sender port. If, for example, C1 is issuing such a message, switch will forward it to this port, to this port, to this port, to this port, and every other port except this one, because this is the sender. So sender do not need to listen to this message. It already knows about that. So, but the other ports, they need to hear to this message. So switch port, switch forwards this to every port. That's it. This is a hazard. You know why? Because if I try to send a lot of such messages to my ports, I'm going to kind of choke them. I'm going to kind of, fill them with unnecessary traffic. I am using their bandwidth. I am using their process time, the computer's process time to, check for messages that they do not, ask about it. So this is a hazard. And actually, some hackers try to issue millions of them in a second and try to, make my network suffocate. So this is not a good thing. So except the broadcast, are there any other messages that create such a hazard for my network? Yes. Search has a default behavior. Search check for a destination MAC address. And if it can find the destination MAC address in its CAM table, it will forward it to the number to the port that it finds in its CAM table. If it cannot find any entry in CAM table, what it should do is this. It should forward this to every port in the hope that one of those devices connected to that port has this destination MAC address. So what happens when this device is, for example, computer 8, assuming that computer 8 has never sent in a message, so switch does not know anything about its MAC address. Computer 1 tries to send a message to computer 8, and switch does not know computer 8, so it tries to forward this message to every other port. It's to every port, of course, not every other port, to every port. except the one that is originating this message. So computer 8 receives that message too. It tries to reply to computer 1, and on that message, computer 8 sees the source address of computer 1. So it does not need to answer using a broadcast message. Computer 8 sends the first Unicast message, and it is destined to computer 1. Switch 1 receives this message, and it knows the destination address because computer 1 has issued some messages, and switch 1 has heard it and has put its MAC address in its MAC address table, and everything is okay. But now that computer 8 has originated the message, switch 1 knows about computer 8 as well. So computer 1 now sends messages to computer 8, and switch does not forward it to any other port. It exactly puts it on the port that computer 8 is connected to. That's it. Uh, but if computer is 8 does not send any message, switch 1 again uses that process, putting this frame on every port in the hope that some of those computers, or one of those computers, of course, has this the MAC address. So this is going to be a hazard too. This is what we call unicast problem, and that can be a challenge in such circumstances. Now, in next section, I want to talk about out of order packets for you.